Right. So this is pretty much programming, and we will be using Java. So therefore, the prerequisite is you are now very comfortable with programming with Java. That is a prerequisite because we are not going to learn Java. Right. And also the object-oriented approach programming, because all these data structures we are going to develop using object-oriented manner. So as the name suggests, data structures and algorithms. Okay. So first topic is introduction to data structures and algorithm. So then arrays and link string. These are some data structures, stacks and queues. Uh, so then trees, graphs. Those are data structures. Okay. So recursion is a programming technique we use in these data structures and later in these algorithms. So therefore, that is not a data structure algorithm. It's a programming technique. You have learned that in semester one also, method calling itself. So then we have the analysis of algorithm. That is a separate topic. So that is a theory behind analyzing the algorithms and check whether which algorithm is more high performance, right? So remember, algorithm must be correct or effective. It must be efficient. So this is a way of checking by analyzing few algorithms and see which algorithm is the best efficient algorithm. And final topic is algorithms. So your subject is data structures and algorithm. Only the topic 8 is algorithms. All the other topics are either programming techniques, analysis techniques, or data structures. The other thing is, while you study data structures, also you learn algorithm because we discuss how to traverse and so on. So those are basically algorithms. So therefore, algorithms are related to these data structures as well. Okay. So exam wise, not very difficult subject at the same time, it's not very easy subject. So if you have solid basis on foundation on your programming, so you will find this subject easy. You will enjoy this subject as well. But if your programming is very shaky, or you don't like programming, right? You don't do practical coding, so you will find this subject somewhat difficult and also right not for you. Okay. So you can see students are expected to do practical and tutorials to strengthen their knowledge of these sections. So this practical oriented subject. Okay. And we'll start with introduction to data structures, and then we'll move on to arrays and linked list also. Okay. Right. So let's start our topic one. I have provided you uh, our note as well as UCSC note. Second topic also our note, some YouTube links, and UCSC note. So third topic also it goes like that. Our note, UCSC note. Sometimes we have two notes, break it into two parts and so on. Okay. Right. So let's start with introduction to data structures and algorithms. So if you have any questions, you need to ask because the subject is all about building your confidence. Okay. Right. So we'll discuss what is a data structure, what is algorithm, so practical usages of data structures and algorithms, and other benefits of studying data structures and algorithms. Okay. So a lot of students forget about these other benefits of studying. Right. So what is mean by data structure? So data structure is basically how do you represent your data? Remember in structured programming, programming is all about representing your data and process it so that you get your expected results, output. So how do you now, in order to process your data, first you need to represent your data. So you represent your data using data structures. So far, we have been representing data using variables, arrays, bit of collections. But now we are going to learn about some more sophisticated data structures, like stack data structure, list data structure, tree data structure, graph data structure, so that we can solve more sophisticated problems. So remember, when we process, if you have the data in a proper data structure, it's easy. Okay. So selecting the correct data structure really help doing your processing correctly and effectively, efficiently. So then someone will think that, okay, data structures are only for structured programming. No. Yes, structured programming, also we need data structures to keep your data so that we can do processing. So in object-oriented programming also, remember the object encapsulate data and process, data and methods, data and services. So your data must be encapsulated into your classes. So therefore, again, you need data structures. In fact, all the data structures we discuss in this particular subject, we develop those data structures as object-oriented way classes, stack class, queue class, node class, list class, tree class, and so on. So therefore, don't think that this is structured programming. So this can be used in both structured programming and object-oriented programming. And we are more interested in using data structures in object-oriented manner. Okay. So there are two types of data structures. Of course, there are different classifications. This is one classification. So one classification is simple data structure versus abstract data structure. So simple data structures are the data structures that we have already used, like a simple variable, int x, x equal 10. It's not abstract data structure. Right? It's a basic data structure. Sometimes we call it primitive data type also, right? Primitive. Primitive means very basic. So then you can have something like array. So that is also very simple data structure, a little bit more complex than simple variable, but it's not an abstract data structure. Its purpose is just keeping few data. Here just one value, here keeping few values. But other than that, this array has no other specific meaning. Okay? No other specific meaning. It's therefore it's also sort of simple data structure. Okay? Simple variables, simple arrays. So most of these are built-in available in your language. For example, simple variables you have in Java. Arrays you have in Java. Not only Java, even PHP, right? JavaScript, Python, C, C++, all the languages. These simple data structures are built-in provided because those are the basics. Okay. So therefore, we have already done this. There's nothing to learn about simple data structures in this subject. So the second type is abstract data structures. So abstract data structures are a little bit more high-level data structures, and it has a bit of more meaning. So I'm not saying that the simple data structures are meaningless, but abstract data structure has some sort of a speciality. It represents a particular concept also. Okay, that data structure, rather than just keeping data. Okay? For example, stack, queue, list, tree, graph, those are abstract data structures. So when we say tree or binary tree, it has sort of a special meaning in that data structure. Okay. When we say graph, it has a specific meaning. It's a special data structure. Even stack. So those are abstract data structures. An abstract data structures has some special operations, special features, restrictions. Sometimes you can't do whatever you want. Restrictions, for example, array, you can modify any value at any time, right? So you can say this is x, say x1 equal 10. So later you can say x1 equal 20. But if it is a stack, you can't touch these data. You can only operate on the top. You can only push and pop. So when you restrict, all of a sudden it is not array, it is a stack. Okay. So then someone will ask, why do we want to restrict like that? Because then we can use these data structures to solve some problems, represent some special type of data. Okay. Then why do we call it abstract? Because we define those data structures at abstract or conceptual level, so that we can implement it in different ways as well. Sometimes just one way, sometimes multiple ways you can implement it. Because what we're interested in is that concept of the data structure rather than how it is implemented. Of course, we are interested in how it is implemented also, but that conceptual data structure has some meanings, usages, and so on. Okay. So the implementation is up to the developer or the development team. What is the best way? Okay. Sometimes you don't need to implement. Sometimes those abstract data structures are available in your programming languages, but you must use them knowing what you are doing. For example, in Java, you have a list. List is abstract data structure, but you don't need to implement it. You can use Java list, but sometimes Java list is not ideally fulfilling your requirement. So then you need to develop your own linked list. And again, these data structures are not depending on your programming language. So these data structures can be implemented in any language, right? For example, if it is stack data structure, you can implement it in Java, C, C++, C Sharp, Python. Okay. So the list is list, stack is stack. It's a concept, abstract. Right. So this is a classification of abstract data structures so that we can better understand because we
So,
have to cover all these data structures in your syllabus.
sir, I have a doubt.
Yes.
Does simple data structure means it's for storing and abstract data structure means it for organizing?
Yeah. Anyway, organizing is also sort of a storing, right? So abstract data structure has some specific way of storing. Yeah. We can use maybe we can use the word organizing also. So that different organizations, different organizing, right? You, you organize your data in a binary tree, you organize your data in a graph. It's not just the organizing. Yes, maybe after organizing, it helps us to do certain type of processing and so on as well. It's not just this organizing. That is why I told you that when you learn data structures, you learn with algorithms as well. Because every data structure, there are different operations. So then you need to develop those algorithms. So therefore, when you learn abstract data structures, it's not just organizing your data. Your data structure defines some algorithms also, possible algorithms. So for this data structure, these are the possible operations. For example, if it is stack, you can push and pull, pop. If it is a queue, you can enqueue, dequeue. If it is linked list, you can traverse, you can delete. Okay. If it is binary tree, there's different ways of traversing, and those operations have some practical usages. Right. So we can categorize abstract data structures into three: linear abstract data structures, non-linear abstract data structures, and other. Other means it's a special category. So on the linear means your data is organized as a line. Those elements are related linearly, right? Like linked list, stack, queue. Array is not a very good example because array is not really abstract data structure. Anyway, I just took this from the internet, so therefore it has array also. But array is not a very good example. You can see array is not in any of these categories, but other. Okay. So the non-linear data structures, now it's not linear like this. You can see it's non-linear. It's grow like this graph. It's not linear. It's like a mesh. So these are more linear, right? Linear, right? More linear. But these are non-linear data structures, especially trees and graphs. So then we have the hash tables, which is a special case. So you can't say it's a linear or non-linear because it's a different, it has a special purpose. Okay. So therefore we'll take it separate. And we are going to cover all these things, plus some more special cases of these things. Right? Some more special cases of the
Does hash means hash map?
hash map. Yes, hash map and hash table is the same. So remember in Java collections also there's something called hash map. But here we discuss what is the idea behind hash map as an abstract data structure. Okay. What is the idea? What are the practical usages? For example, when we do our database subject, so still we haven't started the data management system. So one of our big topic is creating indices. So there's one type of index called hash index, tree index. So then you again use these data structures. For example, there's an index called tree index. There's an index called hash index. So tree index is related to linked list data structure. Hash index is related to hash table data structure. So therefore, your database subject is connected to data structures. So that is why we started data structures before your database. Because you can't discuss those things without first having the idea about these data structures. Okay. So some data structures built-in available, like Java list, set, map, and some data structures we need to create our own. Even Java has queue, queue, priority queue. Those are there. But even though you use your built-in data structure, you must know what is it, how it is internally implemented, what are the possibilities. For example, that is why you have different type of list, array list, linked list, okay, different sets, different maps. So that is different implementations. What are the processes and forms? And sometimes Java list is not going to work. You need your own list because maybe you need double linked list. You need a skip list. So those are not available built in. So those are you are supposed to develop and use it. Okay. But once you understand the concept, you are not going to write the code afterwards. You can just ask ChatGPT to generate code, but you must know what it does. Okay, what it does. But for the exam, yes, you must know how to write basic operations and so on. Because exam is one thing, doing things is another thing, right? So exam checks whether you have that basic understanding, basic skills. So then, of course, it's all up to you to build on that confidence. Okay. So this is another classification. So the first classification was simple data structures like simple variables and arrays versus abstract data structures like stack, queue, linked list, trees, graphs, and so on, maps, and so on. So this is another classification, static data structure versus dynamic data structure. So this is applicable for both simple structures and abstract structures. Some simple structures can be static or dynamic. Your abstract data structures also can be static or dynamic. So the main feature is static data structures have fixed size. Dynamic data structures can grow and shrink. Dynamic. Memory can be allocated, more memory can be allocated, memory can be released. So a very good example of static data structure is something like a simple variable, like int x. So that is why when there's a limit, right? Beyond that size, you can't, it's a garbage, and then you need to go for low. Another one is array. So when you create array, you say what is the size? Say x equal new int 10. So then you can't have more than 0 to 9. So you can't add a 10th element to the Java array because arrays are fixed size in Java. But some other languages, arrays are also dynamic. Arrays are dynamic. For example, in PHP, you can just add another element to PHP array. It's dynamic. So it depends on the way the programming language has implemented. Okay. Sometimes fixed static data structures are better, sometimes dynamic data structures are better. We can't say what is the best. It depends on your usage. Okay, depends on your usage. Especially when you are really concerned about memory, static data structures are better. But when you are more liberal about your memory and you are looking for more and more flexibility, dynamic data structures are better. So now what is the new trend? Go for more and more static data structures or dynamic data structures? Anyone? Can you guess?
Dynamic,
Yes, dynamic. Why? I just
because it's more flexible.
yes. So these days, resources are not the big things, right? So now we talk about terabytes of data and so on, right? So now we talk about internet speed, right? So if someone asks, do you need more internet, higher internet speed than my internet service provider has provided me? I will say, no, this is more than enough for me. So my SSD is more than enough for me. So these days, the main concerns, we are more interested in flexibility because resources are abundant. Okay. So therefore, the new trend is go for more and more dynamic data structures. But it doesn't mean that static data structures are bad, because sometimes these restrictions also good. Okay. So then, of course, dynamic data structures are more flexible, whereas the static data structures have, for example, if you create a Java array size 10, then if you want to add a 11th element, you can't. You need to create another array and copy existing data. Big array and copy existing data. That is the only way. So therefore, it's very rigid. Okay. And this memory allocation is fixed at compile time. At runtime, you can't change it. But dynamic data structures, memory allocation is changed, decided at runtime. So almost all our data structures, we will be developing them as dynamic. But some data structures we will develop as both static and dynamic. For example, we will develop a stack as a static data structure, dynamic data structure. Queue as a static data structure, dynamic data structure. But other data structures like trees, graphs, we will develop mostly as dynamic data structures. So memory usages wise, okay, sometimes dynamic web data structures can be efficient, sometimes static data structures can be efficient. It depends. So why sometimes static data structures are better? Because we know what is the maximum data. Here you don't know. Bit of guessing. Bit of guessing you need to do. Sometimes that guessing is better. Sometimes that guessing is waste of memory. Okay. So speed wise, usually static data structures are faster because it's static. We have a very good idea about the structure upfront. So here resizing is not possible. You need to create a new structure or new variable, but here it's dynamically rearranged, resize. Right? So arrays, static stacks, static queues, those are static data structures. Right? Dynamic stacks, dynamic trees, graphs, linked lists, those are dynamic data structures. So when you work on a particular data structure and its implementation, always think, is this a static implementation? Is this a dynamic implementation? Am I using a static data structure, built-in static data structure? Am I using a dynamic data structure? So therefore, at the end of this subject,
So
yes.
does string class is dynamic or static?
So internally string is array. Internally string is array, but the way they have allocated internally they handle it as a dynamic. So that is why when you create a string, you don't specify the size. I mean I refer to Java, right? So you can simply say x equal high, then you can say x equal some big string. So therefore, internally it is a array, but Java has internally, right, make it dynamic. Make it dynamic. So that is why strings are considered as a special data type. If it is static, you will run out of options, right? After some time, you might get error saying, though, this string is too big for the variable. You don't get that kind of error, right? Because internally it is handled as dynamic. Right. So what are the features of a good data structure, whether built-in or our own abstract data structure? So in general, abstract data structures are better. Why? Because those are high level. Implementation is up to us. There's a flexibility of implementing it the way we want, the best possible way. So concrete data structure means you are given the data structure. I'm not saying that concrete data structures are bad, but abstract data structures, we have a bit of more flexibility. And also good data structures are reusable. We can reuse that data structure in many places, solving many different type of problems. For example, we can use graph data structure to solve different type of problems. Even Google Map is based on graph data structure. Facebook is based on graph data structure. You know that Facebook is one type of application. Google Map is another type of application, but both use graph data structure. And good data structures are efficient. That means it's implementation. Good data structures are flexible, like dynamic and so on, because we need more and more flexibility. So these are past paper questions, okay? What are the features of good data structures? Right. Then the algorithms. So algorithms are processing logic. Okay. Algorithms are different processings. Step-by-step procedure for solving a problem or accomplishing a task. So how do you accomplish that task? By processing. And these algorithms may depend on specific data structures. Sometimes your algorithm doesn't depend on a specific data structure, but sometimes your algorithm is bound to a particular data structures or set of data structures. So by the way, anyway, when you process, you are processing data, right? Your data must be in some sort of a data structure, even simple variables or a list or stack, core, whatever, right? So therefore, algorithms are not independent from data structures. So the idea is you use the best possible data structures and the best possible algorithms. So then your program software is very effective. So these are some well-known algorithms. Whatever the software you write, you will be writing some algorithms. There's no doubt about that. But these are some well-known algorithms, reusable algorithms, like searching algorithms, linear search, binary search, sorting algorithms, bubble search, bubble sort, quick sort, okay. Traversing algorithm, traverse data in a binary tree, binary heap, traversing data in a graph, depth first traversing, breadth first traversing. So there are some optimization algorithms, especially optimization of transportation, optimization of network, data packet transmissions, like all these route algorithms, routing algorithms are based on graph data structure. So some of the algorithms we learned here in this subject are used in computer networking subject because those routing algorithms are learning related to our data structures. Okay, so you can see it's wide range of usages are there. Right. So we discussed about the features of a good data structure, right? So what are the features of a good algorithm? So you can think about it, right? Because these are the possible questions and some of the past questions as well. Can someone tell me what are the features of a good algorithm according to your whatever come to your mind? If there's a question in the exam, list down 3 features of good algorithm.
Efficient.
Yes, good algorithms are efficient. So before efficient, what is the first thing? Because efficient comes late.
Effective.
Effective. So the good algorithm is effective. That means it does the work, it solves the problem. That is number one. If it is not effective, no point being efficient, right? But after effective, yes, efficient. Good algorithms are reusable. Good algorithms are simple because you, for the same problem, 3 people, 3 engineers may come up with 3 different algorithms. And sometimes all 3 work. All 3 are effective. So then maybe we are looking for what is the most efficient, what is the most simpler, what is the more reusable, what is which one is more general so that we can use it in other places. So likewise, so you must know what are the features of a good algorithm. Okay. Effective, efficient, reusable, simple, general. So therefore, when you develop a software, right? So part of that software development is best select the best possible data structures and process using the most effective and efficient algorithms. So whenever you develop a software, so that should be in your mindset, consciously or unconsciously. Pick the best data structures, process the possible way. So then your software is high quality, reusable, maintainable, efficient. Okay, right. That's it about the introduction. We'll do not much past paper questions from this topic because this is just introduction, right? But I think there is 1 or 2 questions. Again, we are not going to, at the end of this, we are going to do only MCQs because all the second paper questions for the last 3 years, we are going to cover during the class. Okay. So there is a new tactic we use in our classes from this year onwards. We cover as much as past papers in the classes. We don't keep it for the last. Okay. Right. So this is 2021 question 1, B1. So discuss two main differences between static and dynamic data structures. So we have already discussed, right? Static, dynamic.
So this paper we have an essay type paper.
Sorry.
This paper is an essay type paper.
Yeah, this is structured essay. You don't have the essay. In semester 3, you have the structured essay. This is we are only taking the structured essay question. We don't take MCQ because as I told you, we are going to take MCQs to the end, last. Okay.
Yeah, for this paper, how many MCQs and how many structured essays come?
So we have shared you the past papers. You can just download and see.
Okay, sir.
Okay. So in our Google Classroom, I have shared you from last year papers onwards, about 5 to 6 years of papers. So you have 1 hour for each subject. In level 1, you had only MCQs, 2 hour MCQ. In semester 2 and 3, you have 1 hour MCQ, 1 hour structured essay. So that means you have about 20 to 25 MCQs, and the number of structured essay questions depends on the subject. Most of the time it is 2 questions, sometimes 3 questions, and all are compulsory. There's no optional things in your BIT, okay? Everything is compulsory. And your marks are 50-50. MCQ 50%, structured essay 50%. Right. So what are the main differences? Obviously, static data structures, fixed size. Right, fixed size. This is not fixed size, not fixed. Okay, what else? So these are more rigid. These are more flexible. What else? When they say 2, at least discuss 3. Okay. So these memory,
Static is more efficient,
yeah,
flexible.
efficient, yeah,
Dynamic is flexible.
be debatable the efficiency because it sometimes depends on, right, the context as well. Okay. But memory allocation, static memory allocation is at compile time. Compile time means it's fixed, not dynamically changed at the runtime. But dynamic, the memory allocation is dynamic. Right? Runtime memory is added, memory is released. But that kind of a flexibility is not there in static. Okay, so likewise, you need to explain it. Yeah. So efficiency is little bit debatable, but you can go with the points mentioned in your UCSC note. Right. Right. So this is another question. B2, this is B1. When selecting a suitable data structure for a particular application, the following characteristics are advantages: efficiency, reusability, abstraction. Obvious, right? So good data structures. So this about data structures, not algorithms. They are efficient, reusable, abstraction. So efficient means the processing of the data structure, right? And the memory usage and so on. Discuss how the above characteristics are advantages in client-side implementation. Right? So this client-side implementation, you don't need to think very seriously because whether client or server, these are the same concept, right? So these are the same concept, but you can little bit refer to the client side. Client side means usually if it is a web application, browser side. Right. So can you give me some special features you need to consider when it comes to client side? Now, this is not data structures and algorithm. Your common sense. The examiner basically check whether you have this common sense, because then you can customize your answer. Can you tell me some special features, process, cons when it comes to client side executions? Special restrictions, advantages. Then you can customize your answer. your data structure knowledge, you need to customize it for this client server, or this is basically connecting web development and data structures and algorithm. Any special thing you want to mention about client or server? Good, bad, restrictions, flexibilities.
More simpler.
Sorry?
Client side have to be more simpler than server side.
Why? So remember, whenever you give an answer, I always ask why. That is my attitude, okay? Because I don't
Because they need only to use what to do only, not how to do.
why not how to do? That means you don't process in the client side. Is that what is mean by not how to do?
Uh, User have to focus on minimum essential things. So how to do will be more.
Yeah. So I think what you try to tell is, in client side, we must do more and more collection of data and give it to the server and let the server process it, right? Is that something like that? Not because how to do is processing, right?
Yes, it's like a modularization.
Okay. So it has process and cons also, right? If you take all your processing burden to the server side, think about an web application where you have thousands of users accessing it. Now you take all their processing to the server. Remember, client is client machine, right? So if you utilize the client machine's resources, sometimes it can be advantageous also, because then you have less processing in the server side. That means less memory, less processing. But at the same time, doing processing in client side can be really risky also, because you don't know the performance of the client machines. Maybe those are not very high-end machines. So therefore, it's very gray area. It's very gray area. Okay. And again, when we have more and more powerful machines, taking processing burden to the server is not very difficult thing. But at the same time, when you do session handling and so on, you will learn that the new trend is, reduce the burden for the server and give more and more at, responsibilities to the client machine, because then your processing burden is distributed. Even now, session handling is most, we try to do it using client side rather than server side. Okay. But in general, yes, client side has less
So
memory.
does that mean?
Sorry?
So does that mean we hide the complexity for the client side?
No, I didn't get your question. What is your question?
Does that mean client side hide the complexity so server will hold the processes?
No, it depends. It depends. So that is why we have different software development architectures. So one approach is try to rely less on the client's machines and do more in server. Another philosophy is give more and more responsibilities to the client side so that your servers don't get unnecessary burden. So these are debatable, and it depends on your preferred architectures and so on. Right? Sometimes a particular architecture will work for your internal applications because you have the control of your client machine. Sometimes when you are not, you don't have the control of your client's machine. Sometimes that architecture can be risky and so on. Okay. Right. But anyway, if it is efficient, reusable, abstract, whether it's client or server, it's always beneficial, right? Right. So let's first look at the in general efficiency. So if a algorithm is efficient, that means customer or the user get quick response, which is good. Whether it's client or server, it's always good, right? You get the quick result that increase the user satisfaction. So therefore, in client side also, at validation or whatever, if you can do it quickly and give the results, so that customer will happy, right? Efficient. Always, if it is efficient with the client or server, it's good. And reusability means mostly we like reusability in the server side, but even client side, maybe we can reuse that validation library for other software, other modules as well, right? So therefore, reusability again, whether it's client or server, it's benefited. So abstraction means again it's more general solution, reusable, those are interconnected. Right? It's very hard to relate it 100% to the client side, but try to relate it to client side as well. Like for example, customer satisfaction is high when you have high response time and so on. Okay, you can reuse some of these client libraries. Okay, so this is the model answer from the answer sheet. Efficiency, it make the program very efficient in terms of time and space. You can see this is not referring to the client or server, right? So just general answer. Provide reusability means that multiple client programs can use the data structure. Now you can see a little bit related to client program. Multiple client programs can use your algorithm or data structure. Sorry, in this case, data structure. Abstraction. These provide the level of abstraction that the client cannot see the internal working of the data structure. So it does not have to worry about the implementation part. The client can only see the interfaces. Anyway, it's a very technical answer because there's nothing called client can't see it, because at the end it is implemented in your browser, right? But abstract means it's more reusable, flexible, whether it's client or server. Okay. Right. So that's it, because in the other papers, they have not asked any of these questions, because they are more because these questions are actually easy if you get this kind of question, right? Because they have more things to ask. Right, so we'll take a small break. After the break, we'll move on to our first data structure. Actually, first we will look at one of our basic uh, built-in data structure called arrays. So then we'll move on to our first data structure, that is linked list. Okay, abstract data structure called linked list. Now we move on to arrays. Actually, arrays is not your first data structure. Arrays is something basic. It's not abstract data structure. Array is a basic data structure that we use to develop some other abstract data structures. So therefore, in your syllabus, they have given a small revision on arrays, and nothing new you learn in this subtopic. You have learned everything in your semester one, so therefore I'm not doing any coding level things, just refreshing, because you must be really comfortable using arrays when you develop other data structures like stack queues and so on, because we use arrays as underneath data structure, one of the underneath data structure. Okay. For example, you can implement stack as an array-based stack or linked list-based stack. Queue as array-based stack, linked list-based stack. So array-based stack is static, linked list-based stack is dynamic. Okay. Right. So remember, array is collection. Basically, it's a set of memory locations allocated. When you create an array, set of memory locations are allocated so that you can assign multiple values. Right. So arrays are a collection of elements, and each element is accessed using index. In Java, index is always 0 base, 0, 1, 2, 3, and 4. You can create 1D arrays, 2D arrays, 3D arrays, or any dimension. So arrays are very simple to use and fast access runtime, because what you get is consecutive memory locations. When it comes to arrays, you get consecutive memory locations. So therefore, in general, it is faster to access array elements. Okay, and also it needs less resources like memory compared to other, especially we compare arrays with linked list. Always arrays need less memory than linked list. Accessing array elements are faster than accessing linked list. Okay. Right. So what are the usages of arrays? Of course, we use arrays to store data and retrieve data. And we can modify, update values. Other than that, nothing. Because arrays are not specific abstract data structures. Okay. But arrays can be a useful basic data structure to implement other abstract data structures. Because arrays are very simple and efficient. So your array can be 1D, 2D, 3D, and even you can extend it to 4D, 5D. But most of the time, practical usages are for 1D and 2D. But sometimes 3D, 4D is used when it comes to data mining and that kind of data science, data analysis kind of applications. Okay. So these are the array operations: declare an array, create an array, assign or modify values, and retrieve. And retrieve specific value was to retrieve all the values, like traversing. So in Java, arrays are objects. Size must be specified at array creation time because Java arrays are static. Array can keep both primitive and object types. Array index is 0 base. Okay, 0, 1, 2, 3. Right. So when it comes to 1D array, so this is how you create a 1D array. Either this approach or this approach. So this approach, if you know the values, this approach, if you want to assign values later. Okay. Here you don't give the size because size is determined by number of elements. Here you need to give the size. Then you can't have more elements than that. Okay. So you can iterate array using normal for loop or array friendly for loop. So if you want to iterate one by one from beginning to end, always array friendly for loop is easier. But you can only process like this. But if you need more flexibility, like process from right to left and so on, then you can always go for normal for loop. Okay, normal for loop. Because when we implement algorithms, some data structures, we will be heavily iterating arrays. So therefore, first of all, you must be aware, familiar with these things, right? Of course, you must have done this in semester 1. Just a refreshing. So these are the 1D array operations. So print, traverse your data from 0 to last element and print one by one. Right? Print values from the end to beginning. So that is, you are going from left to right, going from right to left, print. Then when your index is given, you return the value in that index. So when you are given an array and a particular value, search whether this value is in the array. Right? So that is another possible operation. If it is available, you return the index. If it is not available, you can send some special value or throw an exception. Maybe you can return -1. Right? So those things you must be able to do. Right? I kept it as exercise rather than giving you the code because arrays you have learned in your semester 1. Right? So implement those methods and maybe you can write a test code to test whether it's correctly done. Okay. And so that is something you can do by yourself because this is not a major data structure. Okay. Uh, so, but don't look at the code. You do it and then look at the code. Right. So that is why I just keep it. You look at this type and implement it. Write a small test code also, test it, and then see whether your implementation is correct. Okay. Right. So the code is there, but don't look at the code before because you have done these things in semester 1. So then deleting an element in array. So remember, Now this is somewhat, say you have data, say 10, 12, 8, 30, 40. Okay. Now you can change a value. Say 12, you want to change it to 5. Then what about deleting a value? Can someone suggest me how to delete Java array element? If you don't want to release the memory, you can, one possibility is you can mark it as a deletion. Say, if it is positive numbers, maybe you can mark it as -1. So you need to have a convention. Say -1 means it's marked for deletion. So that is one particular option. Another particular option is you take these other elements one level to the left side. So then it is 10, 8, 30, 40, and this is now empty. But this is also not a very practical solution, because even though you copy these elements to the left side, still this memory is occupied. This memory you can't release in Java. So therefore, very rarely we do that. Okay. But if you really, really want to release this memory, one thing you can do is create another array. Say if this is size 5, now you create a size 4 array and copy these elements. And then you let this garbage collected. So then of course you release your memory. But very rarely we do that because it's very time consuming, right? Because you need to create another array and copy it. But those are the possible solutions, because these can be some questions, possible question in the exams. Okay. Right. So these are some possible options, but every possibility has some pros and cons. Especially in Java, right? Deletion doesn't release your memory, right? Unless you copy it to a new array. But copying to a new array means more processing. Okay. So therefore, mostly when you want to delete something, we just mark it for deletion, like special number or something, saying that it means that, okay, this value is garbage. Because we can't release that memory to the main heap. Right? So you can see there are a lot of limitations when it comes to Java arrays. So the two big limitations are arrays are not global. Once you create an array of size 5, now you can't add a 6th element. Second thing is when you delete, your memory is not released unless you copy it to a new array. Right? So those are some disadvantages. And also array is a very primitive data structure. Other than you keep and get the data, there's no other abstract logic behind arrays. In a way, that is good also, because that is why we can use arrays as a base for other data structures. Okay. But the big two issues are not growable. When you delete, the memory is not released. Okay. Because Java arrays are fixed size. Okay. But if you use something like array list, so that is dynamically expandable. So if you want to dynamically expand your array, when you delete, release the memory, if there is a requirement, maybe you can suggest don't use array, just use array list. Because array list are dynamic arrays. Right? Array list is a dynamic array. Internally, it is dynamic now. Okay. For example, when you create array list and add these things, so this will go into the 0th position. First position, second position. So therefore, your first element will be 20. Now, if you remove your first element and check what is your now first element, now it is 30 because it has copied. You can run this. You can run this. So that means array list dynamically release your memory. So when you delete your first element, right? So this is 0, 1, 2. So earlier it was something like this: 10, 20, 30. 0, 1, 2. Now you remove your first element. When you remove your first element, now array is like this: 10 and 30. Okay, 10 and 30. So therefore, array list is dynamic data structure. It can grow, it can shrink, but not your normal arrays. Okay, not your normal arrays. Okay, so you must run these things and do some experimentations with normal array list and compare those two, because both are built-in available, right? Right. So then you can extend your concept of array into 2D arrays. So there you have two indices. First index is your row index, second index your column index. Right. So this is how you create a 2D array. Okay, your 2D array can be regular, rectangular, or square type, or you can have different length for your different rows. So then you don't give the second dimension, first dimension only, that means 3 rows. Then each row's number of elements is separately given. So then you can't have assign value to these elements, because now it's not a rectangular square shape. So this is called array of array. You look at your 2D array as array of arrays, or you can assign values like that. So then also it create this kind of a odd shape array. Again, you can't have something like 1, 3 now. Sorry, 1, 2, 0, 1, 2. Okay, because Java arrays are not expanded. But you can create at the beginning this kind of array. But later you can't grow and shrink. Again, you can iterate outer loop, iterate row by row, and inner loop, iterate each row. Okay. Or you can use your array friendly for loop. Right. Iterate your data. 2D array. Right. What are the 2D array operations? Print value row by row. That is exactly what we do here. Return an item or for a particular row index, row and column index pair. Right. So then for a given 2D array, you check whether particular value is there in the array. If so, you send that index pair actually. Else you can say something like -1, or you can throw an exception. So you can implement that also. Okay. You can implement that also for your 2D array, right? And also write a test case. Okay. So there are some problems you need to think about, right? How do you return this? Now, for example, you have array, right? It has some data. Now you send the value, you are supposed to return the index. Say if 30 is here, you are supposed to return 0, 1, 2, 0, 1, 2, 3. So you are supposed to return 2, 2. How do you return 2, 2? Can someone give me a solution? So now you need to write a method. A parameter is an integer, and you are supposed to send this row index and column index as the resulting value, or else you return some special numbers or throw an exception. Anyone? Because that is called software development. Solution designer.
Can you repeat the question, please?
Say you need to write a method where you get the array and the 2D array and the data you are looking for. 2D, that's the two parameters, the 2D array and value. You are supposed to return the row value and the column value of that data. Say if you find that data in row 2, column 1, you must return that it's a row 2 and column 1. How are you going to return it? So there are so many different ways. According to your semester 1 Java knowledge, programming knowledge, just give me a solution. A simple solution that you are going to do, because now you are supposed to return 2 values, right? Because that is the expectation of a software developer, right? When you are given a problem, solve it. That is your job. Your job is not memorizing this and that and pass exams. Your job is solve problems, come up with practical solutions. If you are good at that, you will get good salaries, promotions. Everyone will love you because no one is going to give you exam papers and give you the salaries. So one possibility is you return an array. You return an array. Maybe first zeroth element has the row number. First element has the column. Or you can return object. Say class, say element. It has int x, int y. So you say text dot x value and y value and return that element object. So that other guy, when you return, the other guy can take the xy values. So those are the solutions. So when you learn more and more things, you can see that same problem has many solutions. So because when you write this code, you need to think about how am I going to return the values. Right? So that is why I'm asking you to do these exercises, okay? So then only you have these practical problems, then you think about the solutions. That is what your job. For example, I started my career as a associate software engineer, then software engineer, senior software engineer, tech lead, then technical consultant. Okay. So my final job, my job post was solution designer. So that is my role, solution designer. So why they hired me? Design solutions. Design solutions. That is the job. So the next post is architect, solution architect, design, then architect, of course. Okay. So the solution architect is the highest post software engineer can go. There's no higher post than that. Or else you need to go to the management side and be a project manager. Technical track, engineering track, the highest post is solution architect or the architect, software architect. Right. Right, so this is a bit of a comparison between Java array and array list again. Why? Because Java array is static, the array list is dynamic, right? Fixed and dynamic. So therefore, if you need that flexibility of dynamism, you go for array list rather than array, Java array, okay? Right, that's it. I didn't do any coding because you are supposed to know these things, so you are supposed to do this by yourself, okay? Right. So that's it about arrays. Actually, your second topic is arrays and linked list. So now in our notes, we subdivided it to arrays, one topic, linked list, one topic, okay? Right. So our next subtopic is linked list. Okay, linked list. So now we are in the second topic. Actually, we have covered half of the second topic, not half, just small part of second topic also. So introduction to arrays, 1D, 2D, multidimensional arrays, comparison of arrays with linked list. Now we are into the linked list. Single linked list, double linked list, circular linked list, skipped list. But we are going to discuss how to develop that data structure by ourselves rather than depends on the Java built-in linked list. Okay. So therefore, from this point onwards, when we say linked list, it is not Java linked list. We are going to develop this as our own abstract data structure because then we have more flexibility. More flexibility. We can develop it the way we want. We can optimize it for our usages. Right. So when it comes to your data structures and algorithm subject, when it comes to exam, so examiner asks code level questions from the data structures like linked list, stack, queue. Right. They ask code level things because these are the easier data structures. But when it comes to trees, graphs, examiner usually does not ask code level questions. Rather, they check whether, or the examiner check whether you have understood different concepts. Okay, so therefore, for linked lists, queues and stacks, make sure you do coding, right? But other things like trees, graphs, I don't mind if you don't do coding, that is fine. Or you don't pay a lot of attention to the coding. Maybe you should do the coding, but don't try to remember and sort of things, right? But stack queue, linked list, you must know the coding as well because examiners ask you to sometimes write the code, Java code or pseudocode. That is another thing. In almost all the past papers, if there's a coding question, the examiner says write a pseudocode or Java code. Very rarely examiner specifically asks you to write Java code, right? So therefore, if you feel like that logic is a little bit too complicated, so then try to understand that logic in pseudocode because you can write it in pseudocode in the exams. But if it is a very straightforward, you can straight away write it in Java code as well. Okay. So, right. So let's move on to linked list. This is a huge topic, big topic. Okay. So we need to do, because we need to do it at code level, it takes more time. Right. Linked list data structure. This is our first abstract data structure. This is our first abstract data structure. And not only this is our first abstract data structure, we can use linked list as the basis for some other abstract data structures also. That is another thing. One abstract data structure can be used to build another abstract data structure. For example, we can use linked list to build stacks, queues. So as implementation mechanism. So therefore, if you don't understand linked list, you will not be able to understand stack and queue implementation also. Because stacks and queue can be implemented using arrays or linked list. So you must know both. So then you will not be able to understand how to implement the stack and queues if you don't understand linked list. Okay. So what is a linked list? As the name says, linked list is list of link elements. So we have link elements. So we call them nodes. So this node is linked to this and so on. Okay. And this is a linear data structure. So usually linear data structures are easier to understand, easier to implement. Okay. And there are different type of special linked list. First, we will look at single linked list. So then we will look at double linked list. In your notes, mostly double linked list are called double linked list, but I prefer the simple double linked list. Then we will look at what is meant by circular single linked list. And finally, we will look at what is skip list is. So those are the 4 type of list we are going to look at. And we are going to look at those in a very serious manner, include coding. Okay. So we'll start with single linked list. So single linked list means we have set of nodes and each node is linked to another node, another node. And your final node is not linked to another node because there is a final node. So then it is linked to something called null value. So if a node is linked to a null, that means that is the end of the linked list. So therefore, what is a linked list? It's set of nodes linked linearly. Right? Set of nodes linked linearly. Each node can keep a data and each node can link to another node. Last node also can link to another node, but if it is not linked, that is your last node or the tail node. Another name for last node is tail node. Tail node is a node which is referring to null. All the other nodes are referring to another node, but not the tail node. And when it comes to developing a linked list, first of all, you need to model node. That means you need to create a node class so that we can create node objects. So in our linked list class, we will keep track of what is head, nothing else, right? So we only keep track of head. Because from head, we can traverse and find anything else. Okay, so therefore we just keep track of head. Okay. So this is how you can visualize it in the memory, because this is more brain-friendly way of looking at linked list. But in reality, your data is in memory. So this is like memory-wise level representation of a linked list. Say this is my first node. It's in say memory location 1 and start say memory location 1. So that means this is my first node. It has the value, particular value say h. Now it says the next node is at location 4. Therefore, my next node is this one. It has a value e and it's linked to 7. So this is my next node. This is my next node. And this is my next node. It has O and it says -1. There's no memory location called -1. That means this is your last node. It's something like null, but this is how you implement it. Okay. Just give me 1 minute. Right. So this is the memory level view. So abstract view at more memory oriented. So this is more compute oriented. This is more human oriented way of looking at a linked list. or single linked list. Okay. So this one has more details. These are all from your UCSC note. Okay. So we keep track of start. This is more practically how it is done in your memory. Okay, hardware level. So we keep track of where is your start node. Let's assume it is in the memory location this. Okay. So this is your data. This is your data. And it has the next means your next memory location. So therefore your next node is this. And this is your data. Maybe you can just maybe both are your data or just one. I don't know what is this roll number. Okay. So then its next is 3. So therefore you are referring to this node. So 5. So that means 4 is not used. So 5 refer to 7. 7 refer to 8. 8 refer to 10. 10 refer to 11. 11 refer to 12. 12 refer to 30. And 30 refer to 50. And 15 refer to -1. So that means that is the end of last node. Last node. So then someone will ask why you have some blank here. Blank values here. Remember, this is memory. So there are two possibilities for these blank values. Can someone guess what are the possibilities for these blank values here and there? If you have at least gone through the linked list node before coming to the class, you may have a little bit of guessing. Think about it, right? So when I ask question, it gives you an opportunity to think. Maybe your answer is not correct because sometimes when I ask a question, I'm not expecting answer. I just want to check whether give you an opportunity to think because linked list you have not learned, right? So therefore, when I ask a question, it's
Is it
just
to modularize?
sorry.
Is it to modularize? Is it like
No,
grouping?
no, not to modularize. So there's no reason. That is not the reason. So one possibility is maybe earlier these locations also you had not, now you have deleted. That is one possibility. So therefore now these locations are available. That is why we say avail. Okay, now it is available because later you have deleted after creation of this linked list. Another possibility is these memory locations are earlier used by another program, right? Another program. So therefore you were not able to use these memory or your program was not able to use this memory location. That is why it goes from 5 to 7 rather than 6. Maybe it was earlier used by another program, those memory locations. Maybe now that program has released that memory locations. So therefore now those are available. So those are the two possibilities. Those were earlier allocated to other programs and those programs are now no longer running. Or these are earlier your own nodes, now you have deleted those nodes. Those are the two possibilities for these free memory areas here and there. But this is something your OS do, computer OS do. All right. So OS keep track of these memory addresses and also it keep track of what is the first available memory location. So in this case, the first available memory
Sir,
location
but
is 4.
linked list is,
Sorry?
sir, I have a doubt. Is
Yes.
linked list is dynamic?
Yes, linked list are dynamic. Linked list
So
are,
why are they available?
sorry?
So why is that available? So
What you,
it has to be S4 have to come to 4, right? In
Still, I don't.
dynamic. S04 have to come in 4th row, isn't it?
Why?
In dynamic, we study.
If it is dynamic, why do now your question is after this it should go into 4 rather than 5. Is that your question?
No, my doubt was the S04 in row 5. So if
S04
it
is
is
row 5.
dynamic,
Okay.
it has
Yes.
to be go into 4, right? Because 4 is empty.
So that is what I'm also asking, right? So that means you think that this must refer to this fourth one rather than fifth one. So this has to be in 4 means this must refer to 4 and then this data must be here, right? That is what your question.
Yes, sir.
Yeah.
Right.
So that is why I told you, right? Maybe earlier this data was there. Now it is deleted. Maybe that node is deleted. Or maybe earlier this data was occupied by, this memory location was occupied by another program and now that program is no longer running. Right. So the confusion is you think that when we say dynamic, when there's a available memory location, these things must be rearranged. That is what you think, right?
Yes, sir.
Yes, that is your assumption. Your assumption is when a data structure is dynamic, when there's a free location, it must be rearranged to use that. But that is not what is meant by dynamic. So dynamic means it can grow and shrink dynamically. Dynamic doesn't mean that you need to have the consecutive memory locations. Okay. So therefore, this is perfectly okay to have free memory locations here and there. Because if you keep rearranging, whenever you have a free space, you rearrange this, that is overhead. That is overhead. That is not practical also. So therefore, usually we don't rearrange or your runtime will not rearrange your memory so that always you have the consecutive locations because it's a big overhead. Because you need to copy a lot of, because not only this is copied to this, maybe then this is copied to this is to copy to this. It's a hell a lot of copy. Just because you have a free memory location, now you completely rearrange. It is not practical actually. So the practical thing is we keep track of the available memory locations also. So that is why we have this. Now you can see just like your nodes are referring to the next node, right? 5 is next one is 7, next one is 8, next one is 10. So you can see this is referring to the next node. At the same time, so this is your available list, available memory link. So first one available is 4. So then next available is 6, next available is 9. Now this is not next data, next available memory. Next available is 14. So therefore we keep track of all the available memory. We keep track of all the available memory separately. We not only keep track of our memory linked list, we keep track of all the available memory also. Now assume you want to add a new node somewhere, maybe at the end or in the middle. Now what we can do? Say you want to add a new node to the end. Now this is your last node, right? That is why it says -1. Say you want to have data like something like marks is 55, roll number is something. Now what you can do is maybe you add it here. Say now your data is say S. Forget about this roll number. Let's only use the marks. So this is maybe S. Yeah, maybe this is roll number, right? I don't know what is the roll number. Let's look at only marks. Say the marks is 55. So then here you can say, because that is your next node after this node. So here you can say it is 4, not -1, it is 4. So then this refer to this. Now this is no longer available. This is occupied. And now this we can change it to -1, saying that this is the last one. But now your available must be not 4, available starting point must be 6. So likewise, then and there you can again reuse these things. But when you need, you can reuse rather than you keep arranging whenever there's a free slot. So the practical way is just keep track of available memory locations and your actual linked list. When there's an insert or something, you use those next available memory location so that these are also now gradually you. While we use these things again, some memory locations can be again released. That is fine as long as you keep track of both. Okay, you keep track of both. So the idea is use your memory efficiently. Use all your memory. As long as your memory is there, you can keep add nodes to the linked list. There's no upper bound. Your upper bound is how much of memory you have. So your hardware memory is the limitation of your data structure. That is why we say dynamic, growable. So it's very important that not only you look at it in this way, this is how, as a programmer, we look at it, but you must know internally what happens. Right? That is why you learn both computer system subject. Right? So the computer system subject you learn because then you have a better sense about what you are doing, how it is going to be executed in the runtime. Okay, so therefore linked list is growable and shrinkable. So shrinkable means you are releasing memory to this free or available pool, which can be reused later. So, okay. And of course, grow because you can use the next available free space to add a new node. So it is not always necessary that you go like that. So maybe your first node is here, next node is here, next node is here, next node is here. Actually, that is how practically happens rather than you have this kind of a consecutive memory locations. So when you add a new node, you get more memory. When you delete a node, that memory is released to the available pool so that it can be again reused. You don't waste your memory. But bit of a disadvantage of linked list is each node need to keep track of the next node. So that means this node must know what is the memory address of the next node. This node must know what is the memory address of the next node. So that you need to keep. So therefore it's a additional memory usage. It may not be very big. For example, if it is just 1 byte, if you have 100 nodes, that means you need 100 more bytes of memory. But if you use an array, you don't need that 100 byte because then your consecutive memory locations are allocated for your array. You can see there are a bit of pros and cons. So the one of the big disadvantage of the chat of the linked list is you need more memory to keep track of this next node. But it is not a huge overhead, but somewhat overhead is when we have a lot of nodes. When you have millions of nodes, that means you need additionally millions of memory. This is again the same thing. Okay. So this is your first link. Here the available is not shown. First node. So then this node, then this node, then this node, then this node. That means it is something like H, then E, then L. You must be able to visualize it. Okay. Again L, because that data is also L, then O, and that's the end of, then null. Okay, then null. Right. So when it comes to single linked list, right? So there can be some variations of the single linked list. So this is a general single linked list where each node is linked to another node and last node is linked into another. And there's nothing special about this. And we just keep track of the head. That is a general linked list. There's no sorting order, nothing. Just you add another node, depending on your requirement. But you don't make sure any or sorting order or any other business rule. Okay. So second type of a single linked list is sorted linked list. If it is sorted linked list, it always keep your data sorted. Say this is a normal linked list. Maybe your nodes are in the order of insertion. Maybe this is 740, this is 720, this is 780, and maybe this is 750. There's no order. But if it is sorted linked list, it maintain the sorting order. Maybe this is 15, this is 20, this is 30, this is 50. It's now sorted. So when a new node is added, it's always added to the correct position so that the sorting order is not violated. So if you implement it like that, that is called sorted linked list. But if you don't care about the sorting order, just add it next is a general linked list. And of course, using linked list, you can implement stack and queues as well. That we will discuss when we do stacks and queues. Okay. So these are the operations for general linked list. General linked list means we don't implement it as a stack or queue and we don't keep the sorting order. We just keep the natural order of addition. Whatever the way you add it, we keep it. We don't rearrange. Right? Remember in single linked list, we only keep track of that head. So then we can traverse to any other node, and if that node's next is null, you know that that is your tail. But you don't keep track of tail. We only keep track of head. Okay. We only keep track of head. And at the end of this discussion of single linked list, you must be able to explain why don't we keep track of tail? ඇයි අපි tail එක track කරන්නේ? Why we just keep track of head? If you have gone through these slides before the class, that is what you are supposed to do. And have got a bit of an idea about what is linked list. Ideally, you must go through the slides before coming to the class. Then you have the doubts and those things, you are in the class with some objectives. Right? So if anyone has gone through this note maybe today afternoon, can someone tell me in the single linked list, why don't we keep track of tail? මේක note එක කියවපු නැති කෙනෙක්ට මේකට උත්තර දෙන්න බෑ. Why do we keep track of only head, not tail? Because in some linked list, we keep track of both head and tail. සමහර linked list දැන් අපිට හම්බ වෙන ඊළඟ discuss කරන්නේ දෙකම track කරනවා. My question is, why don't we keep track of tail in single linked list? Think about it. I'll give you 1 minute. මුකුත් ඔලුවට නාවක් කවන්න ඒත් හිතන්න.
Sir,
Yes.
is it because of tail refer to empty? So if we track to the tail, we will get out of the array
Yes.
or linked list, sorry.
That is the reason. Because tail is your last node. Maybe just for your information, you can say that, okay, this is the tail. But other than that, there's no use of knowing your tail other than just knowing what is that value. So the reason is these are single linked lists. This node can refer to this node. This node can refer to this node. This node can refer to this node. But from here you can't go there. From here you can't go there. So therefore, just knowing the tail means just knowing the tail, nothing else. Okay. So later we will look at double linked list. Right. So remember we have the single linked list, then double linked list. In double linked list, you will see we keep track of both head and tail. Okay. In double linked list, you can see we keep track of both head and tail. So reason is in double linked list, there's a double link. So therefore, from head, you can using these links, you can go forward. And from tail, because we have another set of links here, we can go this way. So therefore, yes, now this tail is also useful because you can traverse other way. So now you can traverse this way from head or this way from tail. So you can see because it's useful, we keep track of both head and tail. But in single linked list, we don't keep track of tail because it is just the tail. There's no other advantage. Right? So this is a big topic, okay? Very, very big topic. So these are the single linked list operations. Add to head, add to tail, add node to a middle location, search whether particular data is there, like D2 is there, count how many elements are in my linked list, traverse this from head to tail, and delete a particular node. So you must be able to implement those using Java code, pseudocode, because in the exams also they ask code. So now our rest of the task is create a class. First, we want to create a class to represent nodes, then another class to represent linked list, and then implement these operations. And then we want to write a test class to test whether our implementation is correct. Okay. So I forgot to mention one more thing. So one of the purpose of learning data structures and algorithm is, so these data structures are super useful in practical problem solving. And these algorithms are super useful in practical software development. So you get that knowledge, that skill. So that is our main objective. But I told you there are other advantages of learning data structures and algorithms. So I forgot to mention that. Actually, I should have mentioned that at the introduction part. Second reason why you learn data structures and algorithm is, other than getting the awareness about these data structures and algorithms, now you have learned programming subject. Right? You have learned programming subject. Now this is a good opportunity for you to use your programming concepts, structured programming, object-oriented programming, and start develop solutions. So rather than straight away go and develop solutions, inventory management systems, order processing systems, accounting systems, and so on. So this is a nice opportunity for you to think about some conceptual problems, their solutions, and how to design a solution. Right? So, for example, we will gradually implement this. We will gradually understand what is the logic behind these operations and we implement it. So that gives you an opportunity to do some coding, some serious coding. Think. So this is a playground for you to build your software development skills, programming skills. If you don't do these things practically coding, then when you go to the final year, So you are completely struck because you don't have that personality. You can't, right? To develop a system. If you don't do these exercises, coding in a serious level. Okay. Right. So now we are going to look at how these operations are done at conceptual level and then implement those. Right. So remember first we need to model the node, then we need to model the linked list. There we will only keep track of the head because no point keeping track of the tail other than knowing the value. Okay. Right. So this is how you implement the node class. So node is these. So these are the node objects at runtime. Your linked list is set of nodes, and each node can keep a data. It can be integer or whatever, depends on your requirement. Or we can say it's object so that it is a general node where we can keep anything. And every node has a data part, and each node can keep referring to another node. Each node can refer to another node. And if you are the last node, you can refer to as null. So that denotes that you are the last node or the tail node. Okay, so is it clear? Node class, it's a recursive relationship because node is related to associated with another node. Right? Usually class is associated with another class, but this time the class associated with itself because node referring to another node. So we have used object just to make sure that anything can be stored, but even if it is int, that is fine. That means your node can keep an integer or string. And this is your data part. In your node, this is your data part. And this is a node can refer to another node, just one node. Right? Node can refer to another node. And this is the constructor where if you send the object, we set it to our instance variable. So therefore, when you create a node, we can set the data. Okay, so that is our first part. Shall we code it also? Right, so let's create a class. So first data structures we code, but afterwards we don't code. Say node. Say object. Okay, interview not command. Say data. And you are referring to another node. Let's call it next. Okay. And of course, you can write your constructor if you want. Node, object, say data. So this dot data, that is your instance variable data, equal your parameter data. That's it. There is my node class. And I can create node objects. If your linked list has 5 nodes, you need to create 5 objects of node. I told you we are going to use object-oriented approach, okay? Right. So then we need to implement our linked list class or single linked list class. So that's another class. There we only keep track of the head. So then we are going to implement these one by one, add to head, add to tail, delete, traverse, count, and so on. Okay. So there's a small typing mistake here. Okay. So I will just copy paste because it take time otherwise. So let's call it single linked list. So you must code this line by line. Take your time. Okay. I'm just copy pasting because to preserve time. But I'm going to code the method bodies. Okay. So let me convert this to text because the tab character is there. Convert to text. ලස්සනට කෝඩ් එක කන්වර්ට් කරලා දුන්නානේ. Okay. So I will convert the other part also. The tab characters වැදලා තියෙනවා. Right. So these are our methods. These are our methods. So now our task is implement these methods. Okay, implement these methods. Yeah, we can use generics also. We can use generics, but in your UCSC notes and everywhere, they don't use generics for your data structure. So therefore, I don't use generics also. Because when you're writing answers, so you better write answers as closer to the answer sheet. Okay. Yeah, you can use generics, but don't use generics for your exam answers and so on. Okay. Right. So now we have the code, but not implemented. And parallelly, we can use create our test class also. Single link list test or something. Main method PSVM. So you can create a linked list object. So remember, still you have not done agile development. You have the agile development in semester 4. Agile development, one of the concept is test-driven programming. In test-driven programming, we first write the unit test, then write the code. Okay. But then, right, so we create a single linked list object. So then maybe you can add the methods together, maybe add to it. Add to it. Beyond on what? Object. So object can be anything. So integers 25 kilo. Add another one. Okay, then we implement කරන්න ඕන. We have 5, 10, maybe another one. Tail, sorry, 15. Still we haven't implemented. Right. That means your new node must be added to the head side. This is add to the tail side. This is delete a particular object. And this is traverse. Count. Okay. So how do you add to the head? How the head add කරන්න? So there are two scenarios, right? First scenario is this is your first element, first node. Then you create your node and make it your head. Right? Make it your head, and this is naturally looking at null. That is a special case. So you check whether head is null. If okay අපි දැන් code කියලා ඉවරයි. ඔක දැන් develop කරන එක තමයි වගේ වෙන්නේ. ඒක තමයි software developer කෙනෙක් කියන්නේ. So first you need to create a node. Node එකක් add කරන්න බෑද? So n equal new node. මේ data එකම අපි යමු කොහොමද constructor අපි ලියලා තියෙන්නේ. එතකොට යා node එකක් හදනවා. So then if head not equal to null අපි සාමාන්‍ය happy scenario එක තමයි ඉස්සෙල්ලා ලියන්නේ. හරි ඉස්සෙල්ලා ලියන්නේ happy scenario එක. ඒක සාමාන්‍ය ප්‍රෝග්‍රෑමර් කෙනෙක් නේද? ධනාත්මක විදිහට අපි කරන්නේ. null කියන්නේ negative scenario එක. else ඒ කියන්නේ දැන් null. null කියන්නේ තාම මේකට තාම node එකක් add කරලා නැහැ. මේක තමයි පළවෙනි node එක. එහෙනම් මොකද කරන්නේ? head equal n. මොකද reference variable දෙකකට පුළුවන් එකම object එක දිහා බලන් ඉන්න. දැන් n කියන එක නා බලන් ඉන්න object එක දිහා බලන් ඉන්න කෙනා head. මොකද ඔයා තමයි පළවෙනි node එක. Because you are the first node. This is the first node. This is the first node. And this is null කියලා වට කියන්න ඕනේ node එකක් හදුවට පස්සේ ඒක null තමයි කොහොමද. හරි? So that is else part. Then what about the if part? That is not that means head is not null. Head දැන් මෙන්න මේ වගේ තැනක ඉන්නවා කියලා හිතන්න. That means head is not null. This object is there. Then what you are supposed to do? Then කල්පනා කරලා code එක ලියන්න. It is something like this. So then you create your new node. තාමත් new node එක හදන්න ඕනේ. ඒකයි if එක උඩින් ලිව්වේ. New node. So this is your n. Now you must tell your new node. Your next is what head is looking at. Nice. දැන් code කරා. මොකද දැන් head කියන එක නෑ නෑ. head බලන් ඉන්න object එක දිහා work කරා. So therefore now your n dot next equal your current head. දැන් මොන මේක ඇදුවා. දැන් මේක හදලා මදි. This must be your new head. මොකද head එකනේ add කරේ. එහෙනම් මෙයා head වෙන්න ඕන. head equal n. දැන් develop කරලා ඉවරයි. हमने solution එක develop කරා. add to head is done. So if you have any questions, doubts, you need to tell. මේක වරද්ද හරි කරලා ආයි ටෙස්ට් කරනවා හරි නැත්නම් ආයි බලනවා බග් එකක් මොකද්ද. So every time you make a mistake you learn. That is why I told you this is not just learning. A lot of students think that the objective of this subject is learning linked list data structure, stack data structure. Yes, that is one of the objective, but this is an opportunity for you to develop your software development skills. නැත්තම් වෙන්නේ ෆයිනල් එක ගිහිල්ලි වල ප්‍රොජෙක්ට් ක්ලාස් නැද්ද කිය යනවා හිඟන්නවා වගේ. කිසිම යුනිවර්සිටි එක ප්‍රොජෙක්ට් වලට ක්ලාස් කරන්නේ නැත. NSBM එකේ ස්ලිට් එකේ ඇපිට් එකේ ස්ටුඩන්ට් කෙනෙක්ගෙන් අහලා බලන්න පස්සේ පැත්තෙනුත් hina වෙයි. යකෝ ප්‍රොජෙක්ට් එක කරන්න ගමන් කරනවා නේද ප්‍රොජෙක්ට් වලට ක්ලාස් වෙනවාද කියලා. ඊට පස්සේ ආයි ජොබ් ක්ලාස් නැද්ද? නේද? ජොබ් එකට යන ක්ලාස් එකක් ඕන මට ජොබ් එකේ වැඩ කරන්න හැටි ඉගෙන ගන්න. ඊට පස්සේ කසාද බඳින්න ක්ලාස් නැද්ද? අහවල් වැඩේ කරන්න ක්ලාස් නැද්ද? අමු හිඟන්නවා. අමු හිඟන්නේ. ප්‍රොජෙක්ට් එක තියෙනවාට කරන්නනේ ඉගෙනගත දේවල් පාවිච්චි කරලා. මෙන්න ඉගෙන ගන්න තැන මෙන්න. මෙතන බොරු කරගෙන ඉඳලා ඊට පස්සේ ඒකත් කවුරු හරි අනුන්ට කියලා කරවන්න හදන ප්‍රොජෙක්ට් එක. Right. So we can test this. But how can we test it? මේක ටෙස්ට් කරන්න එක්ක මෙමරි එකට ගිහිල්ලා ටෙස්ට් කරන්න ඕනේ නැත්නම් අපිට මෙන්න මේක ඩෙවලොප් කරන්න වෙනවා දැන්. traverse එක. හරි. අපිට මෙමරි එකට ගිහිල්ලා ටෙස්ට් කරන්න පුළුවන්. හරි debug පාරක් දාන්න. මෙන්න මෙතෙන් දාන්න s out එක. done කියලා. මෙතන බ්‍රේක් පොයින්ට් එකක් දාලා ඩීබග් කරමු. ඩීබග් කරන්නේ කොහොමද? ඒක ඉගෙන ගන්න එපා. දැන් software develop කරලා ඩීබග් කරන්න වෙනවනේ. ඒක හොයාගන්න. So now it has executed up to this point and stop. Now I can look at this is my linked list is L, right? This is my L object on head. on එයාගේ date එක 15. හරි නේද? 15. එයාගේ next එක මොකද්ද? It refer to 10. Yes, 10. It's next. It refer to 5. It's next. null. හරිනේ. එයාගේ ඉස්සෙල්ලාම දාපු එක නා. ඔය ඉතින් වැඩේ හරි. ඔය ඉතින් linked list එක ඇදලා. දැන් මේක ලස්සනට බලා ගන්න පුළුවන් අපිට. අනිත් ඒවා implement කරන කණින් අපි implement කරමු මොකද්ද? Traverse method. Because traverse method is the easiest to implement. Traverse. So how do you traverse? Now assume that you have a linked list now. Right? Assume that you have a linked list like this. දැන් මේක හරිනවා ඔයාලට implement කරන්න දෙන්න ඕන. හරි. ඒකත් මම ඔක්කොම implement කරන්න දෙකක් විතර implement කරලා නවත්තනවා class එක. නවත්තන්නේ මොකටද? ඔයාලට opportunity එක දෙන්න ඕන. ඊළඟ class එකේ තමයි මම code එක ලියන්නේ. Okay. So දැනට අපේ situation එකේ නම් මොකද්ද මේකේ තියෙන්නේ? test class එක කරනවා. head එකේ තියෙන්නේ 15 10 5. So this is my head. Then 10, this is 5. And this is null. According to my test code, right? Test code එක රණු මෙයා නැහැ. And this is my head. This is my head. දැන් traverse කරනවා කියන්නේ මොකද්ද? මේක ඉස්සරහට යන ගමන් print කරන් යනවා number එක. නැත්නම් තියෙන object එක. That is the easiest to implement. How do you do that? විනාඩි 5ක් දුන්නොත් code කරනවද ඒක? That means now you're supposed to develop this code. So remember your head is there. Head is an instance variable. ඒ head තමයි මෙතන පාවිච්චි කරේ. ඒ කියන්නේ මේ එක එක linked list object හදන්න පුළුවන් වාට linked list 10ක් නෙමෙයි 100ක් වුණත් හදන්න පුළුවන් මේ object වලින්. So if you need another linked list in your test class, create a separate object. So the object එකක් කියන්නේ අලුත් linked list එක. Okay. So how do you implement this? Traverse. And again, think about the null point exceptions. null point exception තමයි runtime එකේ වැඩිම අපිට අහුවෙන exception එක. program එක crash වෙලා නවතිනවා එතකොට. Happy scenarios, exceptional scenarios. So when you develop a software, you need to think about exceptional scenarios. නැත්නම් එකපාරට run වෙනකොට පුටස්කාර error එකක් පයින්. එහෙම වෙන්න බෑනේ software. Right. I'll give you 2 minutes. Develop කරන්න traverse method එක. පුළුවන් නම් code කැල්ල දාන්න. code එක දිනනවා වගේ note එක බලන්න එපා. So අනිවාර්යෙන් loop එකක් ඕන වෙනවාට නේද? දිගින් දිගට print කර කර ඉස්සරහට යන්න ඕන. නවතින්න ඕන null වුණාට පස්සේ. So the output for this one should be 15, 10, 5 when you call the traverse method. So this is developing solution to a problem. If you like problem solving, if you like challenges, you will enjoy this subject to the maximum. Take 2 minutes. කොලයක් කරන්වත් ලියන්න නිකන් සූඩෝ කෝඩ් එකක්වත්. දැන් ක්ලාස් එක ඉවරනාට පස්සේ ඉතුරු මෙතෙක් ටික ඔය ඉම්ප්ලිමන්ට් කරන්න ඕන. තනියෙන් ඉම්ප්ලිමන්ට් කරනවා ටෙස්ට් කෝඩ් එක දීලා ටෙස්ට් කරලා බලන්න වැඩේ හරියද. tail එකට add කරලා බලන්න, traverse කරලා බලන්න, head එකට add කරලා බලන්න, delete කරලා බලන්න, delete වුණාද හරියට. ආයෙ traverse කරනකොට මැද node එක නම් හරියට delete වෙලා තියෙන්න ඕන. දැන් 10 delete කරාට පස්සේ traverse කරාම 15ට පස්සේ 5 එනවා. ආයෙ deletion එක හරිනම්. ඊට පස්සේ runtime exception පණි, ඒ කියන්නේ ඔය bugs තියෙනවා. So then you can do self study on double linked list, circular linked list. ඊට පස්සේ ඊටු ටික තනියෙන් කරගෙන යන්න ඉස්සරහට. හරි. So the best form of education is self study. Best study is self study. There's no doubt about it. That gives you,
Sir,
yes,
can you repeat the question that we are going to answer?
you are supposed to implement the traverse method. So the traverse method will start from head and keep printing the values in your linked list until you come to the tail node. So you need to start with head. So I'm not going to implement anything. You need to then implement add to tail, delete, count, and write the test code also. But I will just implement the traverse only, right? Because I already implement the add to head. Right. So this is how you implement the traverse. Right. So you create a link to a node. Remember, these are not objects, these are reference variables. I will call it current or something, make it meaningful, and I will initialize it to head. So that means my current is referring to the node, head is referring. Head is referring. In this kind of a happy scenario, my current is now looking at this node. But that is happy scenario. Unhappy scenario is if my linked list is empty, my current is referring to null. Why දෙකම හිතන්න ඕන. Happy scenario, positive scenario, negative scenario. මම ඉස්සෙල්ලා positive scenario එකක් ටැගල් කරලා තමයි negative දේවල් කරන්නේ. මොකද අපි ධනාත්මක දේවල් කරන්න එපා. ඍණාත්මක දේවල් බලන්නේ නේද? අපි හිතමු දැන් අපි ඉන්නේ happy scenario එකේ කියලා. Happy scenario කියලා කොහොමද දන්නේ? Current is not null. Okay? Right. Current is not null. So then my task is I am going to write a while loop. Because it's a loop. Because I need to go to the next, maybe I have 100 nodes. So as long as my current is not equal to null. As long as my current is not equal to null, that means my current is referring to a node, not to null.
Sir,
Yes.
what is the head is like a variable here?
So it's a reference variable. We can have reference variables to objects. So remember the object-oriented programming. Whenever we create an object, we can refer to an object. Right. So you can have any number of reference variables to objects. අපි මතකද අපි කව object is like your air condition. Reference variable is like your remote. So you can have multiple remote referring to the same air condition. So you can see these are two remote controls referring to the same object now. You can have any number of, and afterwards we are going to refer to this air condition, this remote is going to refer to this object. Because this is also air condition, same type. So therefore this remote can be used to control this one as well as this one at different time. Okay. So reference variable and object is two different concepts. That is why we take plenty of time in semester 1 when we do object oriented. Okay. Right. So now if current is not null, that means you are referring to a valid node. So now I can print the data. Say S out current dot data. I will use print, not println, so that I can print it in the same line and maybe a space or something. So then I need to go to the next node, because once you print this, you need to push your current to the next node, right? Because current is not null, but maybe current next is null, that is fine. Because next time we are going to check when the new current is null. So now I will write current equal current dot next. මම null point exception එන්න පුළුවන්ද කියලා කල්පනා කර කර තමයි කෝඩ් එක ලියන්නේ. සමහරට එහෙමුණත් එනවා හිතුව one test කරද්දී. එතකොට මම bug එක fix කරන්න. Now I don't like to get null point exceptions, right? I don't like to get wrong answers. Then and there I will get, but if I get a null point exception, if I get a wrong output, එතකොට මට ලැජ්ජී දෙන්න ඕන. ලැජ්ජී දෙන්න. තනියෙන් කෝඩ් කරලා දෙනවා. Right? Because failures are not something you must enjoy. Failures you must be ashamed of. But in life we fail, because failure is the next first step to success. But failures must not be your natural thing. Failures must be occasional things. That is why I'm always thinking about the possible errors and so on. Okay. Right. So now again, when you say, assume that earlier you were here, now your current is here. Then again you print the current dot data and you push it to the next one. Now your current is here. You write your data, print your data, and you go to the next one. Next one is null. Now your current is looking at null. Then current is not equal to null is false, so therefore you are getting out of the while loop. So therefore no null point exception. No null point exception, that's the end of the loop. You are done. You are done. So therefore I don't need to check whether this is null, because this automatically check that. Automatically check that. If your linked list is empty, what happens? Then your current is referring to null. So therefore it will not execute this loop at least once. So nothing will be print. That is fine, because nothing is there, therefore nothing is print. Okay. Right. So now I'm happy about this. Okay. Now I will call the traverse. So let me stop this. Traverse. L dot traverse, because I implemented that. If there are errors, yes, I will test it. I'm a human, right? I can make mistakes. But if I get an error or wrong answer, I'm a little bit upset also, right? Not little bit upset, I'm very upset. Okay. Right. So let's run and see. What is my expected outcome now? Now my current head must be 15. So therefore my expected outcome is 15, 10, 5. Right? 15, 10, 5. Because the last one is 15, because we add to the head. Let's run. Yes, 15, 10, 5, and done is coming from this, okay? Done is coming from this, so you don't need done now. Earlier, I wanted to do the debugging. Right, correct. Now, if I add another one to the head, say 20. Now my output is, because this is my head, 20, 15, 10, 5. So that confirms that my add to head is correct. Traverse is correct. Yes, 20, 15, 10, 5. Now your task is implement add to tail method. How do you test whether it is correct? Say after here, if you add to tail, say 100, then output must be 20, 15, 10, 5, 100 because you add it to the tail. So then you can test whether add to tail method is successfully implemented. That is why I first implemented the traverse so that you can test. Now your task is implement add to tail, right? For example, if you call this L dot, still of course I have not implemented add to tail, say 2, or let's say 100, or let's say 55. Now, okay, so let's call it afterwards. Now when you call traverse, what should be the output? Expected output. හරියට implement කරොත් runtime exception නෙමෙයි නත් බෑ. So here the expected output is what? අපි දැන්ටම ඇවිල්ලා තිනවා 20, 15, 10, 5 because this is your current head. But after this is executed, my expected output, if you have implemented the add to tail correctly, right? Now this must be added to the tail side, not to the head side. 20, 15, 10, 5, 55. So your task is implement this. Okay. So then implement the count method. Count method. Then the count method එක රින එකයි කියලා වань තාම බොරු එකක්. So here count method must be, once you implement the count method, here it must say 4. මේකට පස්සේ එන්න ඕන 5 කියලා. හරි දැන් එකක් වැඩි. Say L dot count. ඒක S out එක දාන්නේ. S out. මොකද එයා return කරන්න බෑ. L dot count. So I should get 5. If I then I දෙකම implement කරලා ඉන්න ඕනේ ඉස්සෙල්ලා හරි. මෙතන තියෙන්න ඕනේ මොකද්ද? 4. 4. හැබැයි දැන් මෙයා යන්නේ එක print එක. ඒකන්ද මේකට කලින් දාන්න මොකද්ද? print ln එක. නැත්තම් අර අස්සෙන් වදිනවා. Okay. S out එකක් නිකන් දාලා තියන්න නැත්තම් අර පස්සේ වදිනවා හරි. නැත්තම් වඩ පුළුවන් මෙන්න මේක ඇතුලේ print ln එකක් ගහන්න කියලා මේ දාන්න. ඒක දැන් ලස්සන solution එක. So after you do the traversing, you write a blank print ln. එතකොට අරේ ගිහලා print ln එක ගහ ඉන්න ඕනේ නැහැ. හරි දැන්ට මේවට එන්නේ මොනවාද? දැනට එන්නේ -1 කියලා. මොකද implement කරලා නැහැ තාම. හරි. තාම add to tail කරා කියලා 55 add වෙන්නෙත් නැහැ. මොකද තාම මේක implement කරලා නැහැ. දැනට එන්නේ තාමත් මෙතන මොකද්ද? -1 same thing 20 15 10 5 -1. හැබැයි implement කරාට පස්සේ මේ කියන output එන්න ඕන. දැන්ට exception මුකුත් දෙන එකක් නැහැ. හැබැයි තාම add to tail එක implement කරලා නැහැ. count එක implement කරලා නැහැ. හරි. තාම එන්නේ -1 tail එකට add වෙලා නැහැ තාම. හරි implement කරේ නැහැ. add to tail එක තාම empty. But after the implementation, you must get 4 here, this one here, and 5 here. So then you need to implement delete. Delete method එක මොකද කරන්නේ? උදාහරණයක් if I say 10, ඔයා හොයාගෙන යනවා 10 හම්බුණානේ. දැන් 10 අයින් කරන්න ඕන. 10 අයින් කරන්නේ කොහොමද link list එකේ? මෙයාට කලින් එක්කෙනාට කියනවා දැන් ඔයා බලන් ඉන්න ඕන කලින් මෙයා දිහා කියලා. ඉතින් දැන් link මෙහෙමනේ තියෙන්නේ. 1 2 3 4 5. Now then බලාගෙන ඉන්න. Say 20, 15, 10, 5, 45. Say you need to delete 10. So then your this node must direct connected to this node. So then this is broken. And this node is not referred by any reference variable. Then this is garbage collected. If no reference variable is referring to object, that is garbage collected. So effectively, your linked list is now like this. So that is what you are supposed to do in delete method. ඒක ටිකක් අමාරුයි. ඒක ටිකක් අමාරුයි. ඒක කල්පනාවෙන් කරන්න ඕන වැඩක්. So try to implement those things. ඊට පස්සේ delete එකෙන් පස්සේ ආයි traverse කරලා බලන්න. හරි delete එකෙන් පස්සේ ආයි traverse ආයි count එක බලන්න count එකක් අඩු වෙලා තියෙන්න ඕන. right. say l.delete තියෙන එක delete කරන්න. එතකොට හොඳයි. අර 10 වගේ. So then again traverse. දැන් මම expect කරන output එක දාලා තියෙනවා comment එකේ. ඒක එනකම් ආයෙ implement කරන්න ඕන. නැත්තම් bug. delete කරන 10 දැන් මොකද output එක? 20 15 හරියට delete කරොත් 15 5 55. Okay. So then what should be the count? 4. මොකද ඒක delete කරා. දැන්ට එහෙම වෙන්නේ නැහැ හරි. This is the expected output. So you need to implement the delete, you need to implement the count, you need to implement add to tail. Okay. So then single linked list is done. Okay. So then you continue doing your self studies. Code එක බලන්න එපා හැබැයි implement කරපුවා හරි. implement කරපුවා බලන්න එපා. ඊට පස්සේ දිගට කරගෙන යන්න. දිගට කරගෙන යන්න. Right. So any questions?
So what are the applications of this this?
What do you mean by this? Linked list?
Yes.
Yeah, for example, if you take Google Map, so this is application. Say think about Uber Eats. If you have used Uber Eats, Pick Me. Now these Pick Me riders, how they operate? I am not talking about the three-wheel. I am talking about they are delivering food items, right? So now this Pick Me driver, now say I order particular food. So I order it from a particular food stall. So then the food stall accept it. So when the food is ready, the Pick Me application assign it to a Pick Me rider. So then riders can see that there's a possible delivery. So now nearby riders can see that there's a delivery. So whoever pick it first, accept it first, is assigned that delivery. Right? So then this guy is now coming towards this place. While this guy is coming towards this place, if this is about 3 kilometers away, there's another person has made another order. Maybe this is in between this place and the delivery place. So this guy can see there's another delivery. එයා දැන් මේ delivery එක කරන්න අරගෙන යන අතරතුර එයාට තව delivery එකකට අහනවා කැමතිද කියලා. එයා ඒකත් pick කරනවා. මොකද එයාට පුළුවන් මගදී මේකත් අරගෙන ගිහින් කියලා. මොකද සමහරට ඒක deliver කරන්න තියෙන්නේ මේ හරියට. දැන් මේක ඇතුලේ කොහොමද වෙන්නේ? pick me app එක ඇතුලේ. pick me app එක ඇතුලේ link list එකක් තියෙනවා. එතකොට එයා මේක deliver කරන්න යන අතරතුර මේ node එකත් add වෙනවා දැන්. එතකොට මේක deliver කරාට පස්සේ ආයේ current node එක මේක. දැන් එයාට පෙන්නනවා ආ දැන් මෙතන ඉඳලා map එකේ යන්න ඕනේ මෙතනට කියලා. තනිකර link list. මේක delivery කරන්න යන අතරතුර එයා සමහරට තව ඒ මග තියෙන තැනකින් තව මොනාරි pick කරනවා. ඔන්නම තමයි එයාට හැමතිස්සෙම job හම්බ වෙන්නේ. දිගටම job හම්බ වෙනවා. Okay.
So it is depends on the algorithm also.
Yes, algorithm you can implement in different ways. Optimization because it must optimize the fuel usage, time, because there's a time limit also, right?
Yes.
So it need to consider all those things before assigning, giving that opportunity to a rider. Otherwise, rider will take too much of time. Then there will be complaints. So likewise, those are linked lists. So sometimes when you watch a particular video, you will get something similar to that video. Right? So those are sometimes linked lists internally. what is your next video on that particular topic, that kind of a video. So when you keep scrolling, so algorithm decide what is your next video to be shown, what is the next video to be shown. So then AI is also used. So when you use Google Map, you are going from here to here, here to here, here to here. So it's also linked list. And this it shows what is the cost, what is the
Sir,
distance.
so
Yes.
then what the algorithm depends on?
So it depends on the domain. It depends
Domain,
on
okay.
what is your business is. But the idea is add a link, add a node, delete a node, traverse, count. Those are not going to change. But other factors depends on your business domain. Okay. Right. So we stop at this point, right? Thank you.